Welcome. In this presentation, we will review correlation methods using R. Let's delve into the definition and importance of correlation in the world of statistics. Correlation is a statistical measure that quantifies the statistical association between two variables. It helps us understand how these variables change together, providing valuable insights into the relationships within datasets. Now, why is correlation crucial? Understanding correlation is fundamental in various fields. It goes beyond just numbers. It provides us with insights into the relationships between variables. This understanding is vital for making informed decisions across disciplines, ranging from scientific research to financial analysis. Now, let's bring these concepts to life with a practical example in R. The plot you see here illustrates different correlation scenarios based on synthetic data we generated. Each facet represents a specific correlation type: no correlation, positive correlation, and negative correlation. This visual representation allows us to see how different correlation types manifest in data. Take a moment to observe the patterns in each facet. Now, let's move forward with a deeper exploration of interpreting correlation. Shall we? The art of interpreting correlation, a crucial skill when working with data. As we explore different scenarios, pay close attention to the patterns in scatter plots and how they reflect the relationship between two variables. In the first scenario, we have no correlation. When you look at the scatter plot, you'll notice points scattered randomly across the graph. This suggests that there is no apparent relationship between the two variables being compared. It's like trying to find a connection in a field of scattered dots. Now, moving on to positive correlation. As you examine the scatter plot for this scenario, you'll see that points trend upwards. This implies that as one variable increases, the other variable also tends to increase. It's a positive dance where both variables move in harmony. Conversely, in the case of negative correlation, the scatter plot reveals points trending downwards. This signals a situation where an increase in one variable corresponds to a decrease in the other. It's like a seesaw effect, where one goes up as the other goes down. Interpreting correlation involves more than just numbers. It's about understanding the visual patterns and relationships in your data. These insights are valuable in making informed decisions and drawing meaningful conclusions from your analyses. Let's keep this in mind as we move forward into deeper aspects of statistical analysis. Here, we're going to explore the world of correlation coefficients and how to interpret them numerically using a quick example in the R programming language. In the example on this slide, we're working with the iris dataset, a classic in the realm of data science. We're interested in understanding the correlation between different attributes of iris flowers. Let's take a look at the R code snippet provided. What this does is calculate the correlation coefficients for the first 4 columns of the iris dataset, giving us a correlation matrix. Now, let's talk about interpreting these numerical values. The correlation coefficients range from 1 to 1, where a value of 1 indicates a perfect positive linear relationship, 1 indicates a perfect negative linear relationship, and 0 indicates no linear relationship. The closer the value is to 1 or 1, the stronger the linear relationship. The sign, plus or, indicates the direction of the relationship, positive or negative. So when you see the printed matrix, each number represents the strength and direction of the linear relationship between pairs of attributes. Now that we've calculated the correlation coefficients using R, let's take the next step and visualize these relationships. The code snippet on this slide demonstrates how to create a correlation plot using the core plot library in R. Let's break down the R code. In this script, we first load the core plot library, which is a fantastic tool for visualizing correlation matrices. Then we use the correlation coefficients we calculated earlier for columns 1 to 4 of the iris dataset. The core plot function takes care of the rest, creating an insightful correlation plot. Each square in the plot represents the correlation between two attributes, with colors indicating the strength and direction of the correlation. Visualizing correlations helps us identify patterns and relationships at a glance, making it a powerful tool for data exploration. As you run this code, you'll see a graphical representation of the numeric values we discussed earlier. The intensity of colors and patterns in the plot will give you a quick understanding of how attributes are correlated. Thank you for joining this presentation on correlation methods in R. I recommend checking out our GitHub repository for Mind Mimic Labs, https://github.com, Mind Mimic Labs, Machine Learning Toolbox, Tree Main. To access a plethora of R script examples, simply clone the entire repository and unzip the files on your computer. Organize the files in a convenient location for easy reference. The repository is a valuable resource, packed with R examples that can be beneficial for future topics.